So today, what we are going to learn is a very interesting topic, logs or logarithm. Now, logarithms is nothing but power or index. Now, when I say power or index, from the world of index laws, if I say, we'll take an example of 10 square equals to 100. This is the result or just a general number. This 10 is the base, 2 is the index, or power, or now we start calling it as log. One and the same thing. Now so the logarithms are another way of writing indices. In the world of indices, the answer is the result bit. You power the base and you get an answer. This is the world of indices. In the world of logs or logarithms, the answer that you get is a log. The answer that you get is a power. So obviously there is a different way of writing. So the way of writing the same thing that we just talked about, 10 raised by 2 is 100. In the world of logs, so that you get the power in the answer, is log of 100, the result of the index, to the base is written as a subscript, a small number that sits underneath G of the log word G, equals to 2. So logs throw out power as an answer. Log is the power itself. It's called it right at the start. So whenever you're trying to find a log, you are actually trying to find a power of a base that should give you this. So if we have to reiterate it again, if I have this index notation, so the log notation will be what power shall I put this base to get this result? What power should I base to get 100? So the answer is 2. So you raise 10 to the power of 2 to get 100. It's just a flip notation of writing indices. All the laws of indices are also applicable in the world of logarithm, but slightly with a different notation. Now, this was a very easy example. 10 raised to the power 2 is 100. Now, if I ask you, where now you can question, what is the need of it? What is the need? Let's do this question. Let's say, if I ask you, 2 raised to the power x is 8. What is x? 3. X is 3. Why? Because 2 raised to the power of 3 is 8. But if I ask you, 2 raised to the power of x equals to 5, tell me what is x. Now it is a challenge. because it's not a perfect square, cube, quartic, nothing, right? It might be a number, but I don't know that. There will be a number. And there is no other way on earth that I can solve for x. This is not a linear, this is not a quadratic, this is a power. X is sitting in the power. So logs is the answer to these statements, these problems. So if I write somehow this index notation in power, I can write it as log of 5 to the base of 2 is x. This is how we've just explained. This is how you write it. And if I go to a log calculator, which I'll just pop it out. So now on the log calculator, what do we see? Log of 5 to the base of 2 is 2.32. What it actually tells me is that 2 raised to the power of 2.32 is 5. We haven't heard about decimal powers before. Log introduces themselves. That log introduces them to us. This is very fundamentally what logs are all about. Very fundamentally, right? It helps us to solve an unknown sitting in the index, to solve a variable sitting in the index. Now, another example, it could be, if I will not jump onto the laws of log. If I say 2x plus 1 equals to 5, find x. Difficult if you don't know log. So you say log of 5 to the base of 2 is x plus 1. And I know from my previous example, this is 2.32 equals to x plus 1. So x is 1.32. That means that's what it is. This is how you solve unknowns sitting in an index. Log helps you solve that in its very, very simplistic form. Cool, thanks.